Today we're going to be looking at a few security features that we can add into our JSF applications to improve the security of our applications. These won't be terribly complicated things, but they will improve the security considerably and therefore will make sure that your applications are better. A couple of things that you'll need from previous learning blocks. You'll need to know about prepared statements and SQL. You'll also need to know about scopes and attributes, which we looked at a couple of blocks ago, and the JSF lifecycle again. But first of all, let's look at why we should put security into our systems. Just a few statistics. In 2016, reported data breaches increased by about 40%. Now that's the reported ones. Of course, we've got no idea how many unreported occurrences there were. Nevertheless, the ones that were reported increased considerably. Yahoo announced the largest data breach in history, which was more than 1 billion accounts that were affected. ESEA, one of the largest video gaming communities, discovered a breach. 1,500,000 records had been added to its database. And leaked records included a lot of private information. In the same year, Snapchat was targeted by a phishing scam. 700 current and former employees were tricked into giving away personal information. Verizon Enterprise Solutions had 1.5 million customers' details stolen. Multiple email providers, more than 270 million email usernames and passwords freely available on the Russian underground. That's pretty astounding, isn't it? And so security that is supposed to guard against that sort of problem is only as good, like any chain, as its weakest link. Now there are three major components where things can go wrong. There's the network services, the host operating system, the applications and their services. And being developers, of course, it's never our problem, is it? Oh, it's the network people. They should be guarding against this. Host operating system. Of course, it's their problem. Blame it on Microsoft, why don't we? Everything else is. It's never our problem. Think again. In 2008, this is what the Gartner Group reported, more than 70% of current business security vulnerabilities were found in software. So it's not so much the network and it's not so much the operating system. It's you and me writing our software. So we have to be rather mindful of that. In 2012, Information Week stated, developers must take the time to code cleanly and eradicate every possible security flaw before the code gets into production. When was the last time you thought about security in any of your applications that you were writing? The primary target of hackers, cyber criminals, and nation-state warriors, doesn't that sound like a grand title? Something to aspire to? Maybe not. Is insecure code. It's the code that you and I write that is the primary target of these cyber criminals, because that's where most of the flaws are. So we need to try to guard against that. There are some things that we've already been looking at on this module that we can use to good effect, and then there are a few other things that we'll talk about today. We've already been looking at validation of input data, just to make sure that the data types are correct, the format and the length and the range are correct, that there aren't null values when there shouldn't be, that could be used to try to force an error. And that's how a lot of the hackers work. They try to break the application to force some kind of error in the hopes that the error message is going to reveal something. All of this validation is really important because it prevents internal errors. Don't rely on client-side validation. You can put client-side validation into your applications. A typical one would be to put in some JavaScript in your HTML and then have the JavaScript do the validation before the submission of your application's form data. Only trouble is that JavaScript could be turned off on the client side, and so you have no guarantee at all that the data that arrives server side has actually been validated, even though you might have provided the validation software in the XHTML. So don't rely on that. Always, even if you are pretty sure that the client-side validation has happened, always validate server-side. Validate the output as well. For example, Something that we've done in some of our illustrations on this module is get some input and then echo it to the output. Don't do that. We only did that on this module to illustrate a point or two. But to do that for live software in a real-world web application is not very advisable, because it allows hackers to match input with output, and that can provide a mechanism for insertion of malicious data. You could also make sure that the output is correctly formatted. Correct formatting will include, for example, encoding the output data so that any malicious code that got through the input validation does not compromise subsequent requests that will come in from the output that we've just produced. Don't display developer information on output. Now that sounds a bit obvious, doesn't it? It's easy done. You don't provide one of your own custom messages, and so you get one of the standard messages. And what comes out of those standard messages will possibly include information about the internal workings of your application. Variable names, maybe table names in the database, and things like that. You try to do some kind of SQL operation and you've got your code wrong. The SQL command is wrong. An SQL exception would be generated and thrown. If you haven't handled that properly, it's very possible that the user will get some horrible screen with the stack trace for that exception, which might very well include column blah blah does not exist in table, whichever table you're trying to access. That immediately gives a hacker a name of a database table. There are lots of things that we've got to watch out for just in the simple things. And it doesn't take a lot of effort to write your own custom message that will handle or report things in a meaningful way to the user without revealing internal workings. Now, buffer overflow is something that is a problem. We might well have seen it in terms of denial of service attacks, where the hacker will attempt to force an input buffer to overflow, just pile in so much data that the system can't handle it. It overflows and basically grinds the application to a halt. Again, usually this is a problem that is related to input validation, output sanitation, making sure that the output is clean, and data injection flaws. And we've talked about data injection a few learning blocks ago. I gave you an illustration of it. Go back and review that if you need to. Data injection will attempt to inject SQL commands in the form data that gets submitted. If we handle that properly, then it will never be a problem. Making use of a prepared statement will very quickly deal with that problem. If we're not using prepared statements, then we are leaving ourselves vulnerable to data injection. I've already mentioned the improper error handling. Never ever let one of your exceptions escape into the user's world. They should never see it on screen. It should always stay contained within your system and only an appropriate user-friendly error message displayed. That way you're making sure that there are no internal details escaping from your system. And we've seen several ways in which we can put in our own custom validation messages, custom converter messages, custom required messages, and so on. Those are very easy things just with attributes to put onto the XHTML components, UI components. Other things that are quite simple to do and very easy to fall into: forget to use secure communications between client and server. And very often it's just as simple as putting an S after HTTP, because that will then cause the web browser and the server to communicate in a secure fashion, to encrypt the communications before they're sent. I would suspect that it's actually quite common for us to be able to find private and confidential information, such as username and password, being transmitted in plain text. And it only needs someone to listen in on a particular communication for them to get that plain text information. So just put an S after HTTP and that will immediately solve the problem. The first bit I've just been talking about is the transmission of data in plain text. But then of course there's the problem of storing information in plain text. You leave a whole load of passwords in your database in plain text, and it just needs somebody to either gain direct access to the database to be able to read off that information, or perhaps with a little bit of SQL injection to extract that information from the database, and out come all those passwords. A fairly straightforward way of guarding against that is to use a hashing algorithm. Now the thing about a hashing algorithm is that it's a one-way street. You can take the plain text, a password for example, and convert it using the hashing algorithm, but you can't get back again from the hash code to the plain text. That's why it's secure. But if you're going to store your password in your database as a hash code, you've got no way of getting back from that hash code to the plain text for when the login occurs. So the way around that is to take the plain text that has been transmitted as the login credential and convert that using the same hashing algorithm, and then compare the two hash codes. The one that's stored in the database and the one from the password that was transmitted to you. Now there are some minimum security goals that we need to focus on: confidentiality, integrity, and availability. Confidentiality means that we protect private information so that only authorized access is permitted. You don't want somebody else looking at your bank account details. Integrity means that we want to ensure that our data is always accurate and that it is the data that we put in there or that we update or that we delete. Availability means that the data is available in a timely and reliable fashion. We don't want the application falling over because somebody's done something that they shouldn't have done and it's killed the software stone dead. Identification and authorization is one way in which we can work towards achieving those minimum security goals. Somebody identifies themselves and in so doing can gain authorization for access to certain data. The most common identification and authorization mechanism, of course, is the username and password. When you log into your online bank account, you provide your username, you provide your password. You might even have to provide a few letters or characters from some additional information that you've previously stored when registering your account. And that is probably enough for the bank to say, I know who it is, or rather, I know who is claiming to be on the other end. And because they've been able to provide this information, I'm fairly confident that it really is that person. That's the identification. And now, with that information, I know who is claiming to be on the other end, and therefore I will allow access only to the information that belongs to that person. That's the authorization part. I authorize the person who's just logged in to view certain bits of data, but prevent them seeing other bits of data. As I mentioned a few moments ago, there are two common mistakes: not correctly securing the transmission of this data and not correctly securing the storage of the data. And we need to be careful to do both. The storage part of it can be dealt with using a cryptographic hashing algorithm. The one that we would recommend you use is SHA-256. When you're using Java 8, it's really very simple. It's those few lines of code that's on screen. You'll also be able to use MD5 if you want to. You'll find that example online in all kinds of places, but please beware. Wikipedia, that great source of all knowledge, has reported that MD5 hashing has extensive vulnerabilities and, to all intents and purposes, is broken and unsuitable for further use. So don't use MD5. Now this bit of code that's on screen you'll need for the tutorial exercises that go with this learning block, because you're going to have a little bit of practice of taking some password information and then hashing it before storing it in the database. And again, as I mentioned a few minutes ago, don't store them in plain text, hash them and then store them. So when a password is entered by the user on the HTML form, it will then be transmitted using SSL, the secure socket layer, which is as simple as putting the S at the end of HTTP. And then when you receive it in your software, at some point, presumably in the managed bean, because you don't want the plain password to be stored in the managed bean. So when you get the set method called for the password, set password, you receive the plain text, hash it there, and store the hashed password in your beans property. That way, if you inadvertently have get password called for displaying, it's only ever going to display the hash. It's not going to display the plain password. And then having hashed the candidate password, you can retrieve the hashed password from the database and compare the two hashed values. We talked briefly about CIA in terms of general security goals. Now let's apply them to our web applications. So for confidentiality, use the secure socket layer, use a secured username and password mechanism, which we've talked about just now. And what we're going to talk about in a few minutes is ensuring that login has taken place before any part of the system can be accessed. Make sure you're validating properly on both input and output, and use prepared statements to guard against SQL injection. That way, you've got a fairly good level of confidence that you have protected the integrity of your data. And again, by using good validation and proper error handling, you should be able to ensure the availability of your data so that it is not only timely, but also reliable. So I'm just going to talk through some of the concepts for a login example. You'll need to implement these in the tutorial exercise. We're going to work with a table, a user's table. In this example, we're going to have an ID, a name, a username, and a password. The ID is going to be automatically generated. Now this is for a JavaDB database, and that's how you set up the auto increment for an ID field. So the generated always as identity, start with 1, increment by 1. That will give you the automatic incrementation for each new record. So you never have to insert a value for ID, that will be automatically generated. If you're using Oracle, there's a different mechanism through the use of sequences. And you can look up sequence for Oracle databases online, and it's very easy to do. Now the password, okay, you might say, oh, I'm going to have 20 characters for my password. But don't forget, you're going to hash this value and then store the hashed value. You're familiar with this kind of thing. Provide the username, provide the password, and then either log in or register. And what we're going to do when the login command button is clicked, it's going to activate a command method in the managed bean, and that's perhaps where you want to do the conversion, the hashing of the password. Of course, another place to do that is, as I mentioned a few minutes ago, is to do it on the set password method. So one place or the other, you need to do that hashing so that by the time we start using the data, it's already been hashed. And then you get an error message. You don't say something like your password was incorrect, because that then immediately tells the hacker that the username they provided was okay. So you've got to keep them guessing. Your login credentials are not correct. Unfortunately, that also means it keeps the user guessing. If they're a genuine user who has genuinely mistyped, they haven't a clue whether it's the username or the password that was wrong. Such are the trade-offs in computing. There's always this balancing act to try to maintain. Here it's a balancing act between helping the user as much as possible while at the same time guarding the user's data. If you're registering, well, you're providing some plain text here. On that note, please make sure that your password text box never displays the password in plain text. So type equals password should be the motto here, because you don't want somebody walking past to peer over the user's shoulder just as they're typing their favorite password that they use on every system they've ever used, and you immediately compromise their data integrity. Likewise on the confirm password. Don't forget to make that hidden text as well. When you submit, or on the set password, set confirm password, make sure that you again are hashing the values, and that will take care of the logins. However, what we've got to think about now is what happens when somebody is attempting to access a part of your system without having logged in. Thus far, what you would probably do is provide a login view, make sure that they've logged in, and then perhaps set some kind of value. Maybe it's an attribute on a session scope that says this person has logged in, the credentials are good, let's carry on. Thereafter, every single view can make use of that piece of information. And you'd have to write some bit of code somewhere, probably a managed bean, probably on every single action method, to check the existence of that user credential that you've just put into the session scope. Now that's a lot of code that you've got to keep repeating. Get the session scope, get that attribute that says this user has logged in, check to make sure that it says the user has logged in, and then all of that's a big if statement inside of which is the stuff that you would want to do. And that means that every single bit of code that you write, whenever there's a button to be clicked, has got to do that checking and have an if around its code. Well, that's a vulnerability on its own, because you might forget to do that on something. Now, why would we have to bother with that? Well, it might well be that somebody walking past a legitimate user has spotted the URL in the address bar in the top of their browser and then thought, oh, I wonder what that does. I'll have a go. Then goes and types on their web browser the same URL to get direct access to their bank account page, because there's the URL that tells them how to do it. And if you haven't protected, you will allow them access to that page. They'd have to have a pretty good memory or take a photograph of it or something just to get all the query string if you're not careful. That's another thing. Try not to use HTTP GET requests, because that puts the query string information into the URL and displays it in the address bar at the top of the web browser. So much better to use POST requests. So we've got the hard way of doing things, or we've got the easy way of doing things, which is what's on screen and we're going to talk about now, making use of filters. Now, a filter is an object that can transform the header and content, or both, of a request or response. In other words, we can write a bit of code that can intercept a request and change it or validate it. So what we're going to do with our filters for this particular learning block is to provide a filter that will check the existence of that bit of session scope attribute that says the user's logged in. And that means we've only got to write the code once, drop it in as a filter, and when the request comes in for a given URL, that'll be one of the very first things that is checked before the JSF lifecycle kicks in. And so we're doing this checking before we go any further into the lifecycle. Now, usually a filter won't create a response, but what it will do is provide functionality that can be attached to any kind of web resource, so that we can say, look, there's the URL, so let's put that filter in on that web resource so that when that resource is requested, the filter will activate and will do its stuff. In our example, it's going to be to check the presence of a piece of data that says this user has logged in successfully. So some of the things that a filter can do: query the request and then do some kind of action, maybe block the progress of a request response pair. Let's say the user has not yet logged in successfully, but has requested some URL that is further down the workflow. We're going to block that because there has been no successful login. But we can modify the request headers and data, we can modify the response headers and data, and we can interact with external resources, and so on. So there's all kinds of things that we can get these filters to do, and all kinds of applications of filters. We're going to use it for authentication. They can be used for logging. That's making sure that we have recorded in our log every interaction that takes place, or maybe a subset of all the interactions, just the ones that we're really interested in. So there might be, for example, a filter attached to the login and logout requests that will record in the log the login transaction and the logout transaction, so we can see for every single user when they logged in, when they logged out, how long they spent in the system. All kinds of other things that can be done that are not going to be done on this module, so it's there for your awareness. Now, when we're processing inside a filter, we'll do all that processing inside a method called doFilter. You can see the interface for that. It doesn't return anything. It's called doFilter, and it has a request, a response, and a chain. The request is an object that holds all the information about the request that has just been submitted. The response holds information about the response, for example, where the client is, so that we can send information back to the client. So we can get hold of the output stream and insert information into that output stream so that it will be displayed in the client's response. And the chain, well, we can set up a whole chain of filters. It might be that for a particular resource, we want to ensure that they have logged in, and we want to log the transaction. And so we'd have two filters, one for each. Remember, if ever we put the word "and" into a method name, that says I'm doing more than one thing in here, and we want to split that. So we want to authenticate in one filter, and we want to log in another filter, two separate filters. That means we can then say, for a particular resource, I'm going to have a chain of two filters. And it means that we will, in one filter, we'll do our processing, and then we'll call the doFilter method in the next filter. so that we can have one filter call the next filter, call the next filter, call the next in the chain. So that's the concept. Within the doFilter method, we will have this general approach. First of all, there will be some kind of processing that we want to do before the other filters do their job. And that's where we would put the code for that. Then to call the other filters, we just call from the chain doFilter. And the chain will just work out which is the next one and then call that doFilter method. Eventually, that will complete either successfully or unsuccessfully. However it completes, it might be that there is some processing that we want to do after the rest of the chain has executed. And so this is where we would do that bit of processing. When we're writing a filter, we're always going to have this bit of code here, and then we have to choose whether we want to do any processing before the rest of the chain or any processing after the rest of the chain. So typically, if we were going to do an authentication filter, we would do our authentication here and then pass on the request to the next filter in the chain. Now, this is something that some of you were fighting with in the tutorial in the last learning block. How do I access a managed bean? It can be quite tricky if you look at some of the online resources. Alternatively, you could just use some dependency injection, and it makes it really easy. When you're using a filter, for example, we can inject a managed bean which might be on the session scope simply by putting in the annotation @inject and then the class for that managed bean followed by a variable name. That's all you've got to do. The environment that we're operating in here will go and find the appropriate instance of that managed bean and then store its reference in that variable, and then you can make use of it. So for example, if you set up a managed bean that is called user, and in there you're going to have a property that is a Boolean value, has successfully logged in. All you've got to do is do that little bit of injection and then just test the value of has successfully logged in. If it's true, allow the request to continue. If it's false, then you want to abort the request response process. And it's as easy as that. We're going to create this class that has been annotated as a web filter. We give the filter its name and we associate it with a set of resources. In this example, the set of resources is every single URL pattern for this application. Whatever is requested within this application, this filter will run. Because we've annotated it as a web filter, it means that our class has got to implement the filter interface. That filter interface requires us to provide a doFilter method, as well as an init and a destroy method. So we're going to, well, we've got a constructor that does nothing in this case. You could put some stuff in there if you needed to. We're also injecting the managed bean. In the initialization, the init method, we're storing the filter configuration object here. In destroy, we're going to set that back to null, which is fairly good practice because you don't want any information being left over for a subsequent request. And then in the doFilter method, we're going to do our checking. We're going to convert this request object into an HTTP servlet request object so that we can then call getSession and store that as an HTTP session. The false here means that if the session doesn't exist, do not create a new one. If you leave it as true, it will create a session object if one does not exist. Well, you don't want to do that. We're setting up the login URI as a string, which is going to be the request's context path plus faces/login.xhtml. In other words, I've now got a URL for the login page if I want to send the user there. And then I can get hold of this request.getRequestURI. In other words, I want to know which resource has just been requested. It might be view bank details page, or it might be update customer information page. Whatever the page happens to be, that has got a URL, and check to see if it is equal to the login. Because if it is the login page, I don't need to check if someone has already successfully logged in. So I've now got this either true or false. It's either a login request or it isn't. And now I can test. If it's a login request, then I can just go straight on to process that request. If it's not a login request, then I'm going to go on and check that the user object that I've injected has got credentials that are okay. And if those credentials are okay, then I can go on and process the request. But if they're not okay, it means the user has not successfully logged in and therefore should not be allowed to continue with this request. And in that case, that's the else, I'm going to get hold of the response object, convert that to an HTTP servlet response, and that is so I can call send redirect. And that will send a message back to the client to tell that web browser you need to request another URI, which is the login page. And then the web browser will automatically make that second request. That's it, that's the filter. That's the one that you can use for the tutorial exercises later on. How do we set up in NetBeans a filter? If you right click on source packages and select new, other, and then choose filter in the web category, as we're doing here, then click on next, you'll be able to supply the class name, you'll be able to supply the filter name, you'll be able to supply a package name, and so on, in the way that you're used to doing when you're creating classes in NetBeans. And then you'll be able to write your code similar to what we've just looked at. So by the time you've done all of this in the tutorial, you should then be able to explain why we should write secure applications, to identify the most likely location of poor security, and that of course is your code, my code. 70% of flaws originate in the code. Identify critical areas of focus when writing secure applications, your data, the transmission of data, the storage of data, and so on. All the things that we've been talking about today. The 3 minimum goals for security: confidentiality, integrity, availability. What do they mean? You should be able to describe all of that. And you'll have some practical experience of using a hashing algorithm to convert plain text into cryptographic text and then store that. And then use a filter. So that's quite a lot, but some easy wins really, because they're very small things that will achieve fairly big results in terms of securing your application.